Hi everyone, thanks for joining today's webinar and just a second. Uh, yes, so today's webinar is called How to Replace Spark ETL with Real-Time Pipelines. So we have an expert on the topic who's also a senior product manager here at SingleStore. Uh, Spandana is here with us today and she's exclusively working on these topics. So she has rich experience and has come from Microsoft and has worked on these amazing projects for a very long time. So if you have any questions, anything related to if you have any discussion points, you literally have Spandana with you today for 1 hour. So ask away, and you might be wondering how do we do that. So you have a Zoom Q&A button which is present at the bottom of our console. So we use that to interact with our audience and. As for me, my name is Yukti. I'm the moderator of this session. So I'll be providing the links to sign up. So, yeah, just for everyone's knowledge, we are giving away $600 worth of free credits if you sign up during today's webinar and try it in real time. That's how we recommend you to go along with the flow of the session. But like if you even if you want to sit back and relax, that's really totally up to you. So, yeah, Spanna, can you please move to the next slide? So these are just small rules for the speakers and yeah, like I explained everything. So moving on to the next slide, like if you want to know more about SingleStore, here are our socials and feel free to check them out. And if there's any questions, my email is always open. I'll be sharing everything. And yeah, towards the end of the session, I believe Spandana, do we have a demo for the session?
Yes, we do, Yukti. So that
Awesome.
is the
So yeah, amazing. So I believe that a good part of the webinar will go towards the demo, and towards the end of the session, around roughly 10 minutes, if Spandana's time allows, we will have a Q&A session. And please feel free to ask away any questions, and you can collect them in the Q&A button, and we'll make sure to address them during the session, because it's like our internal policy to take up any questions that come across, and we'll do our best to assist you. So, all right. So I'll go dark now. And guys, if there's any feedback, questions, please feel free to DM me. And yeah, Spandana, please take it away. And thanks for putting this together and bringing this to life.
great, Yukti. Thanks for the introduction. So let me dive deep in. So I may not be looking at the questions immediately, but we have a dedicated Q&A session at the end of the webinar. So we'll be answering all your questions. Great. So today's agenda, let's dive deep in. So we'll look at one of the popular data processing tool, data processing, ETL, whatever you like to call it, Spark. So we look at what Spark is really good at, and where it exactly saves you like a lot of time and money, and where exactly it gets really out of place and it starts to hurt. And we'll also look at what single store pipelines are about and how do they compare with the traditional old method of doing your ETL and transformations using Spark. And so are they really competing with each other, or can you really see which is the better solution for your use case? So we look at that by taking some examples so that's easier for you to understand. So let's look at where Spark ETL is generally used and where is it actually good at. So definitely Spark is a distributed compute tool that is very good at handling, processing huge volumes of data. And so it can parallelize the processing by spinning up many jobs and having compute that can it is elastic as well, so it can take up compute as much as it needs, and it's really great at that heavy batch ETL across years and years of data. If you are not really concerned about the real timeness, freshness, or the query latency. If you just give it its sweet time, Spark is really great at accomplishing a huge and demanding task. And the data lake compaction. So this also falls in the same category of heavy batch ETL. So data lake, Spark is the major tool used as a background worker there. Uh, so where it exactly used? So it is used to compact the many small files that tend to land in the data lake. And so it Spark is also useful for checking the data quality issues. So if there is any bad data that has landed on the data lake, it can run periodically in the background to check the data quality, schema issues, and also compact the data and make it efficient so that the query processors can run efficiently. And same is the case with huge backfills or one-off reprocessing. So somehow your logic got changed and you want to run the entire logic on your huge volumes of data. So that's when you can employ Spark ETL. And the very important use case, it's about large scale machine learning trainings, and by utilizing the Spark libraries, ML libraries. So you'll be able to build like hundreds and hundreds, thousands of features by crunching years worth of data, and also train your models, generate embeddings. So all these are the ML use cases that Spark is also really good at. But when is it that Spark tends to face challenges? So first thing is, Spark is not really a lightweight tool. So there is a lot of ops overhead, like you need to manage clusters, you have to tune the memory and the executors, the compute memory, and you have to set up the CI/CD for maintaining and operating the jobs, creating and operating the jobs. And the entire process of Spark, uh, processing the data, serving the results, there is a latency added here. No matter how much micro batched Spark streaming system that you use, there's always a latency of at least a couple of seconds before the data lands into the serving layer. So Spark itself can't serve. So once it processes the data and gets the uh, consumable data format, it has to put it in a data lake or a further other database so that the BI dashboards or the consumers can consume from it. So as there are two systems here and an ETL process involved, so that is a perfect formula for having more latency and overhead in the entire, like overhead in terms of the complexity of the infrastructure, as well as the maintenance overhead of tuning and maintaining different systems. And this exactly once is also an important property for many of the use cases where you need to process the data exactly once. And it's not natively built into Spark, but it's a tool that is extensible. So you are free to add the logic. You have to build the exactly once logic by implementing your sync in such a way that it's idempotent, even if you get the data again, the sync handles it for you. And also if something like breaks, the recovery logic also has to be maintained. So it's not something native. You have to write the recovery logic by yourselves. Let's say your job failed at a point X. So you have to make sure that you start after X and not process X and the data before it. So exactly once is possible, but again, it's heavyweight. You have to do heavyweight logic implementation here. Now let's see how pipelines compare. So pipelines is one of the SingleStore's popular data ingestion mechanisms. for loading data from streaming systems as well as file storages, cloud file storages like S3, AWS, also from streaming systems like Kafka. And for setting up a pipeline, there is absolutely no extra operations or infrastructure required. It's just one simple SQL statement. And the transformations, so you can stream the data into pipelines, transform the data, and serve as well within milliseconds. So the great advantage here being pipelines is a property that's running inside SingleStore database. So it's an entity that's present inside the database. That way, your ingestion, transformation, as well as serving layer is the single database, which gives you great flexibility in terms of how quick you want the operations to be, and also less moving parts involved, which definitely reduces the time involved and improves the real timeness, and reduces the cost as well, the TCO, overall TCO and complexity. And coming to the exactly once problem that we discussed, so as inserts are happening into a database that supports ACID guarantees, you can easily implement the exactly once by having the idempotent primary keys on the destination table. That way, even if there are duplicate records coming into your Kafka, your table automatically handles it. And coming about the failures, talking about the failures, so pipelines have this native checkpointing mechanism built in. So it measures exactly till what point are the data processed till now. So it makes it easy, even in the case of failures, to recover from that point. Yeah, just give me a minute. Thank you. So apart from all the advantages that we talked about, so SingleStore's ingestion capabilities also offer great enterprise uh, features that like universal data connectivity. So pipelines uh, are great for connecting to streaming sources and cloud file systems, as I have already mentioned. And SingleStore also offers a tool called Flow that is useful for streaming in CDC changes from other databases, as well as useful for data migrations. So Flow is a tool for databases, whereas pipelines are for cloud storages and streaming systems. So all the tools come with enterprise grade reliability. So automatic retries, handling the errors, alerting, monitoring, observability is built into the system, and pipelines are definitely scalable and performant. So we look into how pipelines are able to scale and perform better, even in the real-time use case, serving the transformed data in millisecond latency, shortly in our demo. And what are the use cases that actually demand real time? So where time is actually money, and it is the competitive advantage for any company. So there are cases where minute-old data is highly less valuable than second-old data. So as the data ages, it gets more and more less valuable. So cases like use cases like real-time product analytics, so that you serve recommendations and suggest offers that suit the user's preferences and in-app behavior, and fraud scoring from the for the real-time payments that are happening from the users, telemetry, monitoring and alerting of remote and edge devices, predictive maintenance, logistics tracking. So the use cases are plenty, and every industry is generating huge amounts of data, and real-time processing and decision making is what gives the competitive advantage for any industry these days. Let's move to the demo, where I'll be showing a simple use case of the IoT analytics, the real-time IoT analytics on SingleStore. So for this demo, I have I have my SingleStore deployment here. So you can easily uh, create your own organization. So we'll be sharing the resources of where you can go and create your organization, and you can get started with the free credits, 600 free credits, and as well as there is a free share tier that is forever free. So you can use the shared type of compute that is free forever. And pipelines are available even in the free tier. So this is the landing page. So I have the ingestion section here, and that's where I go and monitor. Uh, so this is the starting page. This is where I go and find what is the source that I want to bring data from. So in this case, I'm bringing data from Kafka. And once you create the pipelines, uh, the ongoing pipelines, all the pipelines that you have created are shown here, the current state, what they're doing, and what is the last batch time. So this is a handy editor I have, SQL editor. So you are free to use the editor, or there is also a notebook interface that you are free to use, so that you can interoperate between SQL and Python as well. So for this demo, I'm using just SQL. So I'm using the SQL editor. Yeah, so here I'm processing real-time events that are sent from many IoT devices, and these devices are periodically reporting the state, like temperature, humidity, and pressure. And so the data is coming in a JSON format, like this is the raw JSON format in which the data is being sent, which shows a device ID, event ID, and the sensor. What is the sensor type? Is it sending humidity information, pressure information, and the timestamp and the actual value? So it's a simple use case. And so my objective, I want to do some transformations on top of this data, and also enrich the data with my existing dimension table, so that this data becomes more valuable for me to make decisions on. And I also want to do some windowed aggregation, so that I can see in the last 5 minutes or in the last 1 hour, how has this device behaved? Are there really any problems? So I really want to do that aggregation. So I'm planning to do an aggregation as well as a computation on these reporting, so that if there is any decision I have to take based on any edge cases or anomalies, I really want to make these decisions real time. So I have created tables here. So one is to store the data, the actual data coming from the readings. And I have information about what is the lowest and what is the highest possible value from a sensor. So this is the dimensions table, where I am storing the, so for a particular temperature sensor, what's the lowest and what's the highest threshold, so that if a sensor is reaching that threshold, it's a perfect candidate for me to raise alerts. So these are the dimension tables that I have already created. And I also have a roll-up table. So for the last 5 minutes, so I'm doing a roll-ups for the 5 minutes. I want to average out and maintain a count of how many events per cent on that particular device. And so I see that there are almost 3 to 4 tables, but I can populate all of them and do the required computation and processing before I populate using just one pipeline. So this is the pipeline that I created, which is reading data from Kafka. So this is a Kafka, local Kafka server that I have, which is sending some synthetic data. And the pipeline uh, itself is pushing the data that it reads into the procedure. So the ingestion as well as transformations is done uh, like parallelly. So it's not like you first load into a staging table and then apply your transformations. As soon as the data gets ingested into the SingleStore database engine, it gets transformed before it lands into the destination database. So in this case, what this pipeline is doing is it's bringing data from here, which is in this raw JSON format, and it's stripping the data into these particular arguments of the procedure called process IoT batch. So it is getting the device ID and putting into this argument of the procedure. And basically the JSON processing, like extraction of the fields from the JSON, is done automatically here. And this is my store procedure logic. So the pipeline is sending the data once it reads into this store procedure. And this store procedure is run before the data lands into the destination database. So this particular store procedure is first loading into the fact table. The fact table is the first table that we have created to store the data. So we are enriching the data uh, by joining it with the dimensions that we already have. By joining it, we compute on the fly whether there is a possible anomaly. And we are even filling this anomaly column. So these are the native columns that are coming from the actual data from Kafka. This is the anomaly column that I'm computing using the transformation. And yeah, created it is when the data got inserted. So these are the different arguments that are sent to the procedure from the pipeline. And you can see that I'm directly inserting into the table. And this is the simple logic for computing the cases where there could be anomalies. This computation is done by joining the incoming batch with the dimensions table, the sensor dimensions. So pipelines are capable of doing transformations that span logics, filtering, and joins, and aggregations as well. So here the anomalies are detected based on the values that I have in the dimension table. If it is in the critical stages, in the critical levels, or in the warning levels, I am storing the anomaly as a critical or a warning. And incremental, in the same procedure, I am running this incremental rollup. So the entire logic runs as a single transaction. So if there is any failure, the entire transaction is rolled back. It's not like a first logic gets done, whereas the other table is left in an inconsistent state. So everything runs as a single transaction. And for this rollup, I'm taking a time bucket of 5 minutes. And in that 5 minutes, I'm counting the number of events that are coming for a particular device ID, and computing the average and the minimum and maximum of the values of that device. So there is a handy SQL statement called on duplicate key update. So whenever the data, let's say I have already computed the 5-minute time bucket, and in the first minute I have a row created, but in the second minute I have the um, row coming again for the same particular device ID. This particular logic kicks in as it's a duplicate key, and whenever there is a duplicate key, all this computation happens. Yeah. This is also a great way to handle the duplicate events. So if there is a duplicate key, you are free to choose the behavior that you want. You want to ignore and replace the older data with the new data, or retain the old data, or do it based on some custom logic you have. So all this is possible for handling the duplicate keys. And yeah, so this is my store procedure. That's basically inserting data into the fact table, doing some computation to detect anomalies, and also aggregating and doing the rollups. And I have my handy tool here that to run some, uh, to add some events into the Kafka. So as of now, the Kafka is stopped. So I'm using the handy tool, Claude Code. It's helping me a lot, and it has played a great part in developing this demo as well. So I'm just asking Claude, insert some unread records. So in the meanwhile, I'll just show currently how many events are there in the fact table. Yeah, so as I was testing, there are already 150 inserted. I also wanted to show how the pipeline looks and what are the capabilities that it provides you for easy troubleshooting and monitoring. You can directly in this page, you will be able to do some important operations on pipelines. You will be able to monitor uh, the state of the pipeline, what is the uh, time it has processed the last record or a batch. So in my case, as I was trying, it's a couple of hours before. Yeah, so it has generated a script and it is inserting into the Kafka. And this is the pipeline insights, which opens a monitoring page called Grafana that shows what the pipeline has done. Let me pick 3 hours. Maybe my testing will fall into it. Yeah. So it shows the number of rows streamed into the pipeline and the size of the data streamed. So as I was trying out setting up this demo, I pumped in few rows and what's the time it has spent. And this is Kafka offsets pending ingest. Like it exactly tells you what's the gap between your current pipeline state and what's the late difference between pipeline's current row it's processing versus at what stage the source Kafka is at. So if it is 0, that means pipeline is already caught up. So when it has just inserted data, yeah, there is a 20 gap that pipeline quickly caught up. Let me see if, yeah, it's asking me more questions than usual. Okay, it has inserted, looks like. Let me go to my editor and do a count star. Okay, just created the script. Okay, yeah, now it has started. See, as soon as the data is pushed into Kafka, we can see it coming in. And let me show you a sample of how the fact table is. Yeah, so these are the raw data points that are coming from my sensor, whereas the anomaly is the column that we are computing based on the value, how critically high or low it is. So it falls into critical category and the warning. And we'll also check the roll up. So as in the so all these are 5-minute buckets. If you see 1355 for each device, it's a 5-minute bucket. And what this roll up actually holds, which what information does this roll up hold is it holds uh, in that particular 5-minute window, how many events did it send, what's the average value, minimum and maximum. So all this is being accomplished by a single pipeline that is doing both the ingestion as well as the transformation, and it is actually serving the data in a ready to use format. So we can build dashboards on top of it, make a real time decision making based on the computed values, in this case like anomaly. And so SingleStore is really great at high concurrency, serving queries in milliseconds at high concurrency. And this makes it a great uh, platform for building data apps, where it's not just one user, one enterprise user who is doing some uh, backend analytics to report to internal teams. It's more of your 100,000 customers are trying to load the dashboards at the same time, and they get served fresh data with low latency. So all this data that has landed into the destination tables are also efficiently served to the end users at high concurrency and huge analytical volumes. So SingleStore excels in that use case, as it's both a transactional as well as an analytical database. Your transactional operations, like here the pipeline is actually doing transactions, it's inserting data, updating data, and at high speeds and high volumes. So transactions are going great, and you will be able to further aggregate and crunch these numbers and serve them to all the users in a highly concurrent manner. And there would be no let's say locking issues. So write is not a write happening on that particular row is not going to lock and make it unavailable to the readers. So a single story is great at serving those use cases. Yeah, so let me see my Grafana dashboard as well to see if the latest rows. Yeah, so I asked it to insert 100 more rows. Uh, I asked my script, and yeah, you can see that 100 rows got inserted at this point in time. So I am joining from India right now. So you can see that it's almost like 11 here. And that's the time shown here. And this is the Kafka offsets. So pipelines actually caught up with the data being generated in Kafka because it's very less 100. So there's not really any latency here. Everything is caught up, and pipeline has picked up all the data present in Kafka layer. So yeah, this is about the demo where I wanted to showcase the ingestion, transformation, and serving capabilities for all your data and analytical needs. Let us go back to the presentation. Sorry. Yeah. So now that we have seen the advantages of single store pipelines, does it mean so you can replace, and this is the best solution available, and it can replace all the Kafka, all the Spark workloads? So it's not really that, not really about that. It's definitely depends on the use case, and we'll have to analyze various parameters to see where pipelines are a great fit versus Spark. So where pipelines can actually be a great replacement for Spark is for the operational use cases where real-timeness is a highly important tenet, where the ingestion transformations can happen in the same database, as well as queries, end user queries also can run in the same place. So for the operational use cases, pipelines are a great fit. And coming to the heavy batch workloads where you want to run um, the aggregations over huge volumes of data, run the custom complex machine learning logic that you have already built. So you can still have your Spark and take the advantage of single store by complementing here. So how single store can help in the traditional batch-based workloads is, so you can run the huge computations of years and years of data and store the data in the data lake, but use single store as the serving layer for that slice of data that's valuable to the users. So the real-time data, let's say, or the last 1 week's data, or depending on your use case, 1 day's data, as soon as the uh, data lands in the data lake from after getting processed from Spark, it can be ingested into single store and can serve the app use cases, as I was saying, where thousands of users can run parallel queries and get low latency results in within milliseconds. So that's where you can use single store to read the latest slice of the data stored in your data lake, and still keep Spark for maintaining the data lake, compaction of the data lake, and maintaining the sanctity of data there. So to bring data from an Iceberg-based data lake, SingleStore has a native Iceberg pipeline as well. So you just need to point SingleStore, like we have seen the Kafka example. It's a similar pipeline where you need to mention the Iceberg catalog and S3 location, and SingleStore pulls the data from that and keeps it up to date with the Iceberg. And you can even mention the filtering category, like the partitioning, as I mentioned about um, single store maintaining last 1 month's data. So you can maintain that partition as well, and not load the entire terabytes of data into single store. You can store the hot slice, so whatever is relevant and important for your users to be served in real time can be brought over. And so, yeah, this is how you can win with simplicity and scale of a single store pipeline. Just point it at your source and start with a simple pipeline, add more transformations using stored procedures, monitor it, and you can even build alerts on top of the Grafana dashboards using our native pipeline alerts. And we'll be there to help you with the required templates, documentation, and we also have our in-house solution engineering team to help you set the system get your data from your traditional Spark jobs, and to see how we can implement a similar logic in single store based pipelines and store procedures. Yeah, that's all from my side today. I'm happy to take your questions as we have time. Yukti, do you want to add anything before we move to the questions?
All right,
Let me.
folks. So now we are officially open for questions. If anyone has any questions, please, this is the time to ask. Just for if anyone joined late, we have a Zoom Q&A button which is present at the bottom of your console. You might be able to see it. If there's any questions, like we have Spandana and she's going to, take up any questions live. So, and if you are like, if anything else pops up in your head later on, you can always reach out to us at team@singlestore.com. So, Spandana, I think we'll just wait for some time. If we don't quite get more questions, we can end the session early.
Sure. So we'll be sharing the resources that
Yeah,
we have presented today, and also instructions on how to get started.
yeah, a recording will be sent, and any resources that Spandana would like to share, I'll draft out an email, and it will be sent to you after the session. So Spandana, it looks like we don't have any questions, so I think we can like skip that part then. I hope it's all right with you.
Sure, sure.
Is there anything else you would like to address?
No, I'm good.
Awesome. So, okay. Thanks everyone for joining. I hope you enjoyed today's webinar. And if you have anything like, that maybe comes to your mind later on, you can reach out to us at team@singlestore.com. You will be getting an email from me, uh, which will have the recording of this session. And any other resources that like if there's anything Spandana, like any blog, any white paper, like just include, like you can slack that to me and I'll add it over there. Okay, so right, so if anyone else like, so yeah, if there's any doubts, feel free to reply on that email, and like I'll connect you with the right folks. And if it's relevant to Spandana, I'll definitely like connect you guys. So right, I think then we can conclude the session a little bit early. You'll all I have like 14 minutes back. So, all right. Thanks, Panna, for joining. And like, I understand so much of effort goes into preparing these webinars. We really appreciate it. And this was an amazing learning session for like, I'm hoping for everyone that joined. So, yeah, thanks everyone for attending, and have a great rest of the day. Have a great rest of the night, depending on where you are. And I'll see you in future sessions. So, all right. Take care, everyone. Bye.